Hi folks, so the question we have in front of us here today, guys, is a question from road geometry, and it comes from the DCG solutions workbook. It's actually a sample ordinary level question. The question itself says the map shows ground contours at 5 meter vertical intervals, and AB is the centre line of a proposed roadway which is level at an altitude of 50 meters. Okay, so first of all we can see our contour lines and we can see our roadway A to B, which is level at an altitude of 50 meters. So that means the height of the road is always at 50 meters all the way from A to B. So what I would always write in there is maybe something here like level at 50 meters. Okay, just to have that written in so I don't have to go back up here looking for it. And it also says using side slopes of 1 in 1.5 for the embankments, and embankments, another word for that, is our fill. Okay, and 1 in 2 for cuts or for cutting. Complete the artworks necessary to accommodate the roadway. Okay, so what we have to actually do is work out our ratio, okay, our fill ratio and our cut ratio and our measurements for that. And also it gives us the scale of 1:1000. What that means is essentially 1 millimeter on our sheet is equal to 1000 millimeters in reality. Okay, so what I often do is inside in class I write 1:1000 and OS, which is on the sheet, and IR, which is in reality. Okay, so 5 meters, okay, is the distance between our contours. So 5 meters is 5000 millimeters. So what am I going to multiply this by to make 5000? I multiply it by 5. Therefore 5 millimeters on my sheet is equal to 5000 millimeters in reality. Okay, just by multiplying it by 5. Anyway, so 5 is kind of our magic number that we're going to use to kind of work for our fills and our cuts. So in our fill ratio, I'm going to write up here fill ratio, and then I'm going to write cut ratio over here. Our fill ratio is 1 in 1.5, and then our cut ratio is 1 in 2. So what that means is for every 1 meter I go down, I travel out from the road 1.5 meters. And then for our cut ratio, where every 1 meter I go down, I travel out 2 meters from the side of the road. Okay, so for our fill ratio here, multiplying by 5, which was our kind of magic number, okay, on our sheet, 5 times 1 is 5, and 5 times 1.5 is 7.5. Okay, so essentially for my fill ratio, I'm going to travel out a distance from the side of the road of 7.5 millimeters, and for my cut ratio, 5 times 1 is 5, and 5 times 2 is 10. So for my cut, I'm going to travel out 10 millimeters from the side of the road. And the reason for that is because 5 times 2 is 10, okay? We're travelling out from the road, okay? Because as we look down on it in plan view, okay, which is what this sheet is, as the 5 meters go down, we can't see that on our sheet because that's going down into the sheet. But we can see the distance it travels out from the side of the road. So 10 meters out, or 10 millimeters as it equates on our sheet. Likewise with 7.5. So 5 meters down and 7.5 meters out. And if we always use kind of like the triangle to kind of basically explain it. So for our fill, it would be a triangle like this, okay, where we went down 5 meters but we went out 7.5. For our cut ratio, it would be like this, so it would be 5 and then 10, so it would actually be a lot longer. So it would be something like that, where it was 5 high and then 10 out. Okay, 10 is the distance out from the road. Okay, so now what we're going to do is we're going to start filling in the earthworks for that area there. So first of all, what I want to do is I want to identify the contours and where I'm going to have to cut and fill. So looking here, I can see this contour here is 50. It's just gone slightly off the sheet, so I'm not going to use it. But looking at the next one, it's 55, 60, 65, 60, 65, or 55, 50. Okay, so we know the road is level at 50 meters. So right there, that's going to be kind of a little pinch point for us. Okay, so right here, and obviously in the opposite side of the road. And I'll try and identify another 50. So it's 45, 40, 35, 40, 45, 50 again here. Okay, so what I often do now is I want to identify where I'm going to be filling and cutting. Road is level at 50 meters, so write in 50 there, 50, 50, 50 for my measurements when I'm doing them in a minute. And in this section here, from 50 to the 50, in between that, we can see that the land is actually higher. So in this section here, we're actually going to be cutting. Where the land is higher than the road, we're going to be cutting. So I'm going to put cut in there. In this section, from the 50 to 50 here, I can see that the land is lower than the road. In this section, I'm going to do a fill. And then from this section here, 50 onwards, I can see it's 55, 60, 65, 70. So once again here, I'm going to be doing a cut. So I'm going to be using my cut ratio there. Okay. So starting off, I'll actually use the cut ratio first. So I'll do the two side parts and then I'll get onto the middle part first. Okay. So for my cut ratio, I know I'm going to have to measure out distances of 10 millimeters. Okay. Or what it would appear in reality is actually 10 meters. So from the side of the road, I'm going to measure out distances of 10 millimeters. Okay. So 10, 20. Okay. So this is actually working upwards when we're cutting. So this is be 55, 60, and I know I have to go up as far as 70 here. Okay, and over here I think it only goes up to 65. So this will be 50, 55, 60, 65, and finally 70, just to have that marked. So 55, 60, 65, and 70. And while I've done that, I'm going to use it then for this section here. So it's over to the 50. So my red lines here are my construction lines. Okay. 65. And then finally 70. And while I'm at it, I'll project them across. So 55. Then 60. 65, and finally 70. I don't think I need the 70 over on this side, so just to have them written in again, 55, 60, 65. Okay, just so I know that. Now what I can do is I can actually plot my points. So for the 55 contoured line that I've kind of done here, what I have to do is locate where that actually cuts through any 55 contour line here, and I can see it cuts through 55 right there. Now the next one is up at 60, so it's going to cut through to 60 here. Next one is at 65, that cuts through to 65. And then this is going to be 70. And I can actually see here, the 60 is below it as well, so there's another 61 there. And then the 55 one right here. And I'd imagine you can see it's 50, so it's probably going to meet the road over here somewhere. Okay, so that's the points that I've located on this side. Now I'll locate them on this side. So here, 55, there's the 60, right there, 65, 65, back down to 60, back down to 55, and as you can see it's 50 again, so I assume it would meet somewhere over there. Okay, having done it on the north side of the road, we also have to do it on the south side of the road. So once again, identifying my contours, and I know I needed 4 of them on this side, so I'll do 4 10s down. So 10, 20, 30, and 40. So once again, that'll be 55, 60, 65, and 70. So for the 55 contour, I know it's going over here, all the way over to this guy here. Just following it down, knowing how far I have to go. For the 60, as far as there. For the 65, as far as here, and for the 70 it's out to this one. Okay, doing the same thing at the opposite side. So this is the 55. Next one down is the 60. Next one is the 65. Pretty sure that's it there. And I don't think I need the 70 on this side once again. So 55, 60, 65. Once again, let's plot the points. So starting with the 55, I've got a 55 here and another 55 over here. Then I assume this is going to be the 60, this is going to be 65. Then I've got the 70, back down to the 65, to the 60. Okay, and the 50 is going to meet it somewhere over there like that. Okay, same thing over here, 55, 60, 2 65s, back down to the 60, and then the 55 is going to meet somewhere over there once again. Okay, so at this point here you can see I've actually got my cut ratio or the cut embankments in. Okay, sorry, no, the cut ratio in for the plot or for the points. So I'm going to start sketching that, so I'll just speed up the video there quickly. Okay. Right guys, there we have it. That there is the cut section of either side of the road, okay. Now inside in here what we have to do is the fill section, okay. And as we worked out previously, what measurement we're going to use for the fill section is 7.5. So if the road here is 50 and 50, we're going to be working here, we worked upwards to 55, this time we're working downwards. And I can see the lowest measurement here is actually 35. So if we think 45, 40, I'm going to have to step out 3 times, okay? So 7.5, 7.5 and 7.5 each time. So just between 7 and 8 is, and take the closest mark you can in between that as best you can. 7.5 plus 7.5 will be 15, and then another 7.5 will be 22.5. Okay, and having done the 3 of those, I will also do it out on the south side of the road. Just making sure I have that correct there. Yep. So from 0 to 7.5 to 15, and there we have it. Okay, so putting in my marks there as well. So this will be 45. Next one will be at 40. And the next one will be at 35. And likewise up here, 45, 40. And finally 35. Okay, so I could write those in, just let the examiner know I know what I'm talking about. So 45, 40, 35, 45, 40 and 35. Okay, plot the points. So this was at 50, which was touching the road. Next one's at 45, then 40, 35, back to 40, down to 45, likewise here, 45, 40, following the contour, 35, 40, and 45. Okay, once again, speed up the video while I sketch that in. Okay, there we have it guys, that is the question completed there. Now the final touch on any one of these road geometry questions is what you're actually going to put in is your tadpoles, or it's called tadpoling. And basically what that does is it either identifies a cut area or a fill area. And they look like tadpoles, but if you imagine it's like a ball that is either rolling away from the road or rolling towards the road. In the case of a cut, if I was to put a ball here and here and here, and likewise with the opposite side of the road, that ball, because the land is higher than the road, would roll towards the road. Okay, so likewise on the opposite side, and as you can see they look like tadpoles. So on the other cut section we would do the exact same. So just put in 2 or 3 depending on the size of the area that you have. So for the sake of a cut, okay, what we have is our tadpoles, or our balls rolling towards the road. In the case of a fill, the road is higher than the land around it, so it's like the ball started at the side of the road, here, and likewise here and here, and it rolls away from the road. There we have it. That is our cut and fills done for that question, and the tadpoles then to identify the direction of the land or in relation to the road. Okay, hope you found that helpful guys. There's another question at the bottom of the page I'm going to move on to now. Okay. Right folks, so the next question on this page, it says here, the map shows ground contours at 10 meter vertical intervals, okay, and our scale is 1 to 1000. So 1000 millimeters is 1 meter. We want to work up to 10 meters, so just multiply it by 10. So 10 is kind of our number that we're going to use, okay. It says on the map, draw a vertical section profile along the line XY. Okay, so we can see obviously the contour map here, and we've got a XY line that is basically slicing through the mountain. Okay, so we're going to have to get the profile of the mountain where that slice is like a vertical cutting section has gone through it. And it also says A, B and C are outcrop points of a stratum of ore. Okay, so there's a layer of ore, be it coal or gold or whatever you're mining for. Determine the strike, okay, and the dip of the ore, so the angle that ore is in the ground at. And then it also says outline the outcrop of the stratum of ore as well. Okay, so part 1 anyway, we'll work on this. It says on the map, draw a vertical section profile along the line XY. So first of all, your scale is 1 is to 1000. So that means basically 1 millimeter on our sheet OS is to 1000 millimeters in reality, and 1000 millimeters is essentially 1 meter. The distance between our contours is 10, okay, as it tells us over here. So what do I need to multiply to get 10 meters? Well, 10 meters is 10,000 millimeters, okay, and we've got 1000 here, so I have to multiply this by 10. So 10,000, 10 times 1000 is 10,000, okay, and therefore 10 times 1 is 10. So 10 is kind of our magic number that we're going to use. Okay, so looking at our contours, we can see we have 60, 50, just trying to see what's the lowest and the highest. The highest is 100, the lowest is 50. So I'm going to imagine the side here is at 40. Okay, and I'm going to measure up in distances of 10 millimeters. Okay, so this measuring up 10 will be 50, 60, 70, 80, 90, 100. Hopefully this all fits in. I think it should just about. Might have started at 50 there, maybe. We'll see though. See how we get on. So this one's going to be at 50, 60, 70. I think we'll be okay. 80, 90, and finally 100. Looks like, depending on how the writing is done here, it should be okay. So 50, 60, 70, 80. Sorry, it's gone a little bit messy up here. Put 90 over here, and then 100. Okay. So what we're going to do now is we're going to plot where these contour lines are cut by that XY line. Okay. So the 60 contour line is cut right here. So that I will project that up until it hits the 60 contour there. Likewise with the 50, so you can see it goes lower, then it goes back to higher. This one's at 60, this one's at 70, 80, 90, this is at 100, goes around to 100 again, 90, 80, 70, 60, 50, then back up to 60. Okay, so it's a case of sketching in that profile, so I'll quickly speed up the video there. Okay, so there we have it. That is the profile by the line XY that cuts across it, and that's basically what you would see of the mountain as you were looking straight at it in this direction. Okay, and now what we have to do is we have to work on to part B. It says here A, B and C are outcrop points on a stratum of ore. Okay, so anytime it says something like that and it gives you the outcrop points, we can see C is along the 60 contour, B is on the 80 contour, and A is on the 100 contour. So what we're going to do is we are going to connect up all of those points to create a plane on the stratum of ore, and it's obviously a triangular plane. Now this is the plan view of it. We now have an elevation view of it here. If you think of our XY line, this is the elevation here, up here in this direction, and obviously we've got the profile of the mountain. So what we want to do is we want to plot those points up in the elevation as well. So I want to find A, B and C up there. So to find those, start with point B, which is on the 80 contour. So we already have the height, so it's just a case of projecting it up as far as the 80 contour, which is along here. So right there, I could bring it up like that. That'll be point B up here. Now I want to find the A, which is on the 100, which is up here. So there's the A. Write that in there. And finally the C, which is on the 60, which is down here. And there's our C. So like we did in our plan view, I want to create that plane as well in my elevation. So triangular surface, okay. Think of oblique planes, kind of like a lamina. And now what we have is we have the elevation view and we have the plan view of what's known as the stratum of ore, okay. And what we want to do is we want to determine a strike, okay. A strike is a level line that is running across that plane, okay. So, and also, sorry, it's the true length of a level line that is running across that plane. And we also want to determine the dip as well, which is the angle that plane makes in relation to the horizontal plane. So to do that, what you do is generally from ABC up here in your elevation, you can do it in your plan as well, but just based on the space that I have in the sheet, I'm going to do it off my elevation. But I'm going to select the middle point here, okay, and I'm going to go parallel to my XY line, okay, because we know a principle, okay, that we have learnt is any line that is parallel to one of the principal planes of reference in one view, wherever that line is in the other view means it is a true length. Therefore, I have done a level line from B parallel to the XY line, okay, in my elevation. That line from B has cut the line AC right there, okay. I am now going to project that down to my plan view, and it has cut the line AC right there. And like I did in elevation, I'm now going to connect that across to B. And what you'll notice is the line in elevation was a perfectly horizontal line and it was parallel with the XY line. Therefore, it was parallel with the principal plane. Okay? That means that in our plan view, that is a true length. And that actually is our true length of our strike. So that's our strike there. Strike. I'll put in TL as well, true length. So straight away we've found our strike. So you could take that off if you wanted. Now what we actually have to find is the dip. Okay? So what we've actually got here now is, if you think of this plane here, it's kind of something like that, okay, if you think of this triangular set square, what we've got is kind of like a line that is running across it like that. And as we look down on top of it, we can see the true length of it, okay? And if you look along a true length, okay, this line here is a true length, the pen. If you look along that and see it as a point view, because it's on the surface of that plane, okay, what you're actually going to do is you're going to see an edge view of that plane then, okay, where the strike is a point view then, okay, and that's what we're going to do. So we're going to look along our strike, set up an x1, y1 perpendicular to that to basically get the stratum of ore and the angle it creates, which is called the dip, okay. So just one independent, I'll actually go out this direction because I just seem to have a little bit more space here. So just a little bit of sliding set squares here. Going to set up the long edge of my 45 degrees on the strike line. I'm going to keep the 36 degrees just underneath it, and then I'm just going to flip it up like that, creating a perpendicular angle there, and keep it quite close up there, like that. That there is my x1, y1. Put that down a little bit further. And what I want to do now is I want to project out point A, B, and C. So a little bit further there. And likewise with C. I think C is actually the lowest one, it's on the 60. Okay, so like I did up here, taking this x1, y1, I treated this as my xy line even though I know the cut section was down here. But that was at 40 there. I know C is up 20, I'm just thinking 60, how high will I go? Yeah, it'll be 4. Shot. I'm actually going to take it down, okay? I'm going to treat this x1, y1 as if it was at the 50 meter height, okay, which is actually here, okay? So it's like I'm taking my heights, it's like a mock height there, a datum line, okay? I'll just say x1, y1 datum, just to keep things neat. Okay. And what I'm going to do is, we know anytime you take your heights, okay, or sorry, you project from the plan, and we're doing an auxiliary here, project from the plan, you take your heights from the elevation. Okay, you could use your compass for this. Okay, so in the case of point C, I'll just show you. We know the distance from here, the datum line that I'm using, not this edge down here. I'm using the datum line from here to C. I know it's 10 millimeters, but I could just take my compass and mark it off like that. So 10 millimeters there. Come down to C, out to my X and Y1. Could mark it like that. Okay, very, very easy. And I would now call that C1. Okay, likewise I could do the same with B, but I know just measuring from here, that's 10, that's 20, that's 30. So for B, I'm just going to measure out 30 millimeters. So from 3 out to 0, depending on which way you're reading with the set square. So there's B1. Okay, and finally for A, 10, 20, 30, 40, 50. So for A, I'm going to step out 50 millimeters. So there's A1, and as I said, what we should see is basically that plane as an edge view, which means we're seeing it as a line. Okay, the plane, okay, but we're seeing it as a line because we've looked along the true length of a strike, which we're seeing now as a point view essentially. Okay, and hopefully if you're accurate, you should get all of these connecting up as a line. Let's see what my accuracy is like. Let's check that. Is that 10? That's okay. 30, 50, and depending on my accuracy, it's not too bad. I'm out a little bit. Usually what I do in that case is try and make it work for you. You can see there I'm probably out a little bit on one of them. Okay, that's close enough. Okay, you might lose a couple of marks for accuracy, but the method is right. And what you've actually got there now is an edge view of this plane ABC. Okay, so I'll write in there, edge view of ABC. Okay, and technically point B is a point view. Okay, and really what we actually wanted here is the angle in there. Okay, so I could continue that down and extend out my X1, Y1, and you could actually measure that there, but really that angle there is our dip. Okay, that's our dip angle, and that is the angle that the plane is making, or the stratum of ore, in relation to our ground. Now what we want to do is the part C. So we've done this bit, outline the outcrop of the stratum. So the outcrop points is basically where that material, be it the gold or the coal, reaches, and it's showing on that surface. On the surface, you can actually see it on the surface. Okay, so what we're going to do is we are going to identify some of those points. So probably should have done this previously, but I'll start here now. I said this was 50, and the lowest it goes to is 50. Thank God. So that's 50. So we're just identifying. So this will be 60. Mark out a little bit further. I'm going to basically set up contour lines here. So that's 60, 70, 80, 90. And obviously there we have the 100. So parallel to your X and Y1. This line that's running through there is at a height of 60. Next one is 70. Likewise 80 here. 90. And finally 100. So I'll write those in. 70, 80, 90, 100. And essentially, where those contour lines are passing through, the 90 right here and the 100, so just marking off the 100 first, okay, right here, where that 100 is passing through, it gives me a point on the outcrop points. Okay, so I've got one right here, and I've also got one here, okay, right there, because that's at the 100 and it's on the 100 contour. Now for the 90, so we're working backwards here, where it cuts through the edge view, or the stratum of ore. I'm going to project that back, make sure I'm parallel there. and that has to go through the 90 contour, and it goes through here as well. We do the whole line, goes through there and there. Likewise, I'm going to do it with the 80, the 70, the 60 and the 50 as well. So this one's at the 80 right there, and the 80 passes through, just finding it, so at the B, and then it's also going to pass through right here as well. Okay, so it's actually passing through there and there. Likewise with the 70, passes through the stratum before here. That's that. Goes through it there and there. So here and here. And the last one then is at the 60. Okay, and I can see here he was on the 60 there, and I assume this is going to be the 60 if we follow it around. Yep, here. The question then is, would it have passed through at the 50, which would have been down all the way down here? So just check. I feel it might actually. Yeah, it looks like it did. So the 50 would have been helpful if I continued it on. There's the 50, and the 50 is going to go, I'm not sure how it goes off the sheet there, okay, but essentially what we have identified there now is our outcrop points, okay, and just put these in. So the 50 is gone off the sheet there. I'm just thinking, I'll put these in here, so I'm going to sketch that in. As best you can. Assume it goes something down there like that. Okay. Now in the DCG Solutions workbook, they might have connected this one over here like this and just brought it across like that, but obviously we can see here if I'd used the 50 and brought it down a little bit further, I do think it would have worked out at that, it would have had a point there, so I am going to put in that one. Okay, just heavy these in. Try and be neat as possible as you can. And I'll continue that, just thinking, yeah, maybe something like that there. Okay, so there you have it. They are the outcrop points, okay, for where the stratum of ore comes to the surface, and it will be seen and it's visible. So that question was a little bit in that, where we did the profile. Then we constructed our plane surface here where the stratum of ore was, ABC, got the level line across it to get our strike line in our plan view. Okay, and that strike line then helped us get an edge view of that stratum of ore, therefore determining the dip. And then we put in our contour lines like we did up here. We just put them in with the x1, y1. Okay, this time we started at 50, and where those contour lines passed through that stratum of ore helped us identify the outcrop points. Okay, so a little bit in that there, guys. Hope you found that helpful. That is the questions complete. Okay.